Hello, everyone. My name is Drew Laws, and I am representing Rock Lake Robotics today. Thank you for joining us, and welcome to the 2020 virtual ARM meeting. I wanted to spend a couple minutes today just kind of featuring Rock Lake Robotics as a company profile, introduce you to who we are and what we do. And if you wanted to set an appointment with us, the page you're on right now, I believe, will allow you to schedule an appointment to visit with us in this virtual meeting. So we look forward to speaking with you. Rock Lake Robotics was born out of a project at Selgen Company in Lake Mills, Wisconsin. Selgen Company wasn't happy after several attempts to source a robot, a simple robot, to trim our parts. We had contacted several automation companies and their integrators, and we were repeatedly, they attempted to sell us much more, a robot capable of much more than what we were asking for, and the price tag was certainly a reflection of that. And after several of these attempts, in classic Selgen fashion, if you know us, we're very vertically integrated, we decided that we would do it ourselves. 50 years ago, the company started as a metals and a fabrication and a tool and die company, and became a rotomolder in the year 2000. So we definitely had the tool and die engineering expertise to do it, and we decided to work with a local dealer of Yaskawa robots, made in Japan, and we became our own dealer for Yaskawa robots. And what resulted as the project resulted as a spin-off company, which was originally called AIT, Advanced Integration Technology. Little did we know that there was another automation company that also used AIT, and so in 2019 we officially changed the name of our company to Rock Lake, not Rock Lock Robotics, but Rock Lake Robotics here in Lake Mills, Wisconsin. And our specialty really is to focus on rotational molding and its post processes, namely trimming, flaming, and spin welding. I want to point out that the trimming function is not deflashing the parting line. That is not something that is readily available for a lot of reasons I think we all know, the part size variation, etc. And so what we've done is we've taken a fully capable robot, 5-6 axis robot, and we have intentionally kept it simple. So we can do the trimming of rotomolded parts, we can flame rotomolded parts, we can apply spin welds, and we don't have vision systems that look for part orientation, that auto-compensate for sizes and such. But it's a simple robot to do simple processes automatically, so your labor force can spend their time doing other things that demand their attention. And I've got a couple of videos I want you to show you of trimming and flaming and spin welding, just to give you an appreciation of what I'm talking about, and we can talk together one-on-one if you have more questions. So one of our robots that we produce has a turntable, and I want to show you that. It's kind of in a sped-up mode, but the turntable toggles back and forth, and we'll be trimming a part while the operator on the other side of the table is loading and unloading a part. It can be the same part or a different part. And so similar to how the carousel rotational molding machine goes around and around, which keeps the operators busy, this turntable does the same thing. I'll show it again. So while it's trimming on one side, the operator is busy working on the other side. On the right side of the screen, I want to show you one of our first robots that has kind of a modular fixture. At Selgen, we produce about 100,000 liners a year, and we wanted a robot that didn't need fixture changing. So we just made a changeable fixture, and that fixture has linear actuators that move in and out depending on the size and shape of the robot to hold it in place. And the robot trims to height and cuts handle holes if we want, in a variety of shapes and sizes throughout the year. We've never changed the fixture, ever, and we trim liners all day long, every day. So this is just a kind of a little clip of some trimming capabilities. I'll show you another one later. We also do flaming. What's really great about flaming is the fixture can be much simpler, simply because the flame never comes in contact with the part. So there's, in most cases, nothing has to hold the part down. You just have to place it in the, you just have to put it down, and the fixture needs to help you place it in the same spot and in the same orientation every time when we play this video. So it's got a typical shrink fast gun, and we've just built a end of arm tooling to use existing shrink fast flaming guns, and then the robot just goes back and forth. We've programmed a path that allows us to flame these dome tops the same every single time. What we found, and I think what a lot of people see, is different operators will flame treat parts differently than each other, and sometimes differently than they did the day before. So sometimes a part will go to a customer far glossier than it did the shipment before, simply because it was flamed differently. So having a consistent, repetitive flaming process is pretty great for product consistency. You'll see there's two parts mounted on this fixture, placed on the fixture. One is the dome top itself, and the other one is the flip door that goes inside, that snaps inside the dome top. So this thing will flame both parts. The flame will turn on and off automatically when it starts and stops. It moves out of the way, and you can repeat the cycle. So if, in as much as your part is sized such that it fits inside the cell of this robotic framework, then you would be able to flame treat your parts. And frameworks can be changed if needed. Here's another couple flaming videos of us flaming some parts. And it's the same part flamed in two different orientations. So the part's just sitting there, and the video going now is going to trim the part horizontally as it moves around the shell of the part. You can see it articulating in and out of all of the features as it moves its way up the part. We had shared this with a potential customer. They wanted to flame the part faster, and so simply by calculating kind of the movement time and the residence time of the flame at different areas, we were able to program it differently. So while this is still going, I'll play the other video, and you'll notice that this video flames it vertically. So it has to travel around the product only one time as it swings up and down, flaming all of the different features. Using the robot, we can actually flame some areas more than others. We can skip areas that don't need to be flamed. And like I said earlier, really find some consistency in this part of the post-rotomolding process that sometimes gets ignored or perhaps not focused on as much. Here is a quick video of a spin welding operation. Now, we don't have spin weld changing capabilities. So what we've done is, after the part's been trimmed, the robot operator is standing by, and the robot will present the end of arm tooling to the operator, who then places the spin weld on the end of arm tooling. You'll watch this in a second. So the first spin weld was already positioned in the tool, and after this is done, it goes and calls a subroutine where the end of arm tooling will present itself to the operator, who will place a spin weld in the fixture, tells the robot that it's done, and it goes into place. It achieves the necessary RPMs, and it places the next spin weld. And it does it the same every single time, same location, same pressure, same dwell time, etc. You'll see the typical smoke. That normally is happening right underneath the nose of the operator, who then gets to inhale it, unless they're in a well-ventilated area. Doing it with a robot allows the operator to remain an appropriate distance away from the spin welding operation. So there he goes. He places another one. We have custom spin weld tools, spin weld drivers that fit more than one type of spin weld. So you can really outfit a part with a variety of spin welds without much effort. What you're seeing here is a prototype fixture, obviously held in place with straps. Customer wanted us to just confirm that we were able to do it before they spent money on a more elaborate fixture. And then the robot will stay in this position until the operator puts one final spin weld in place, which is actually the first spin weld for the next part. So a lot of consistency in spin welding, and a lot safer doing it this way. So finally, here's a video of one of our remote control coolers. It's a combo video where the robot will trim with one cutter on one side of the double-ended router, and then it uses the other end to apply a spin weld. So let's watch this one. So there's a variety of cuts and openings that happen, some holes that get drilled. So the robot is specifically programmed to drill the holes that we need and cut the openings that we need for speakers and control panels, etc. Using a robot to trim, there's not a lot of cleanup by way of needing to scrape cuts, simply because the cuts are so clean. They happen fast, same place every time. So the cut that's happening now is an opening for all of the electronics that go in this remote control cooler. I think many of you have seen that. The first big hole that it just cut below was for a speaker. It'll go cut a second speaker hole now. And finally, it'll turn over. Yeah, it'll turn over and do a spin weld. And at the end of the process, it will go present the robot end of arm tooling to the operator, who then populates it with another spin weld for the next cycle. So it really happens pretty seamlessly. So with that, a little introduction to Rock Lake Robotics. Our focus is you. We make robots for rotomolders, designed by rotomolders, so we have an appreciation for some of the challenges that our process presents. And we focus primarily on robots to do cutting of rotomolded features, separated apart in half, or cutting openings and holes, as well as flaming, as well as spin welding. Like I said earlier in the presentation, if you have any questions for us, feel free to reach out to us, set up an appointment to visit with us, and we'd be happy to visit.